Hello grade 8. In this video we will talk about solving equations and equalities of the first degree in one variable in R. Unit 1, lesson 10 in algebra, okay? And the first here I have some equations like them. First one, 2x minus 5 equals 3, half x minus root 5 equals 0, and root 3x minus 1 equals 8. We note that index of the variable x equals 1. So this equation called what? Or each equation is an equation of the first degree in one variable. First degree in one variable. First degree because the index of the variable x equals 1. And one variable, only I have here one variable, is x, okay? Now, I need to solve this equation. Solving equation means find a real number which satisfies the equation. Like what? Like this. For example, find in R the solution set of each of the following equations. Then represent the solution on the number line, okay? The first one, 2x plus 5 equals 4. 2x plus 5 equals 4. I need now find the solution set for this equation. So I need to separate between the variable and the constant. So I will move the constant to another side with the opposite sign. Like what? Like this. 2x equals 4 minus 5, okay? We get 2x equals negative 1. Now we can divide both sides by 2. So x equals negative 1 over 2, okay? So the solution set is negative 1 over 2 or negative half. The solution set equals negative half. Here we note the solution set of the equation, only one solution or unique solution, okay? Now we need to represent the solution on the number line. Okay, so here on the number line I will put a point on negative half, the middle distance between 0 and negative 1, okay? So this point represents negative half, represent the solution set of this equation. The second exercise here, root 5x minus 1 equals 4. Now, the same idea here. I need to separate between the variable and the constant, so I will move negative 1 to another side with the opposite sign, okay? So we get negative root 5x equals 4 plus 1. 4 plus 1. So root 5x equals 5. Divide both sides of the equation by root 5. So x equals 5 over root 5. Now I have in the denominator root 5 and I need to make the denominator is an integer number, is with a whole number. So I will multiply by root 5 up and down, okay? I will multiply 5 over root 5 by root 5 up and down, okay? So 5 times root 5 equals 5 root 5. And root 5 times root 5 equals 5, okay? You can simplify it. We get x equals root 5. Now I need to represent root 5 on the number line, okay? Now, I will use to represent root 5 on the number line, use what? I will use, or I need to draw right angle triangle. I will draw right angle triangle, which root 5 is leg of it. Like what? Like this. okay? Here, F is right angle triangle, okay? And root 5, one leg of it, okay? Now, I need to find the length of the other two sides, okay? So think with me, think about two perfect square, which number 5 lies between them. Again, think about two perfect square, which number 5 lies between them. Yes, 4 and 9. 5 greater than 4 and less than 9, and both of 4 and 9 are perfect square. So by taking the square root for all sides here, we get what? We get the two numbers, the root 5 greater than 2 and less than 3, okay? Here, what is the greatest number? 2, root 5, or 3? 3. So 3 represents the hypotenuse and 2 the other leg, okay? So from 0, I will draw line segment by length 2. I will draw line segment with length 2 centimeter, okay? Okay, then open your compass on radius 3 centimeter. Open your compass on radius equal to 3 centimeter. And from this point, draw arc. Draw arc. Intersect the number line, okay? Intersect the number line like this. So this point represents root 5, okay? Represent root 5. Now, solving inequalities of the first degree in one unknown in R. In the first here, I have some inequalities like them. 2x less than 5, 2x plus 2 less than or equal 1, and here 2x minus 1 greater than 5 plus x and less than or equal 3 plus x, okay? Here, the index of the variable x equals 1, Therefore, each of the inequality here is called an inequality of the first degree in one variable. First degree because the index of the variable x is equals 1, and only here I have one unknown or one variable x, okay? So the inequalities of the first degree in one variable or in one unknown. Now I need to solve the inequalities in R. Solving inequalities means find all values of the variable x which satisfy the inequalities, and the solution set of the inequality in R, it will be written as interval, okay, because has many numbers satisfies inequalities, okay. For example here, but before solving the inequalities, I need to remember some properties of the inequality to help me to solve the inequality and find the solution set. The first one, let A, P, and C be 3 real numbers, okay? And here, assuming that A less than P, my inequality here, A less than P, okay? And C is constant number. So the first one, if C constant number is positive or negative number, okay? C constant number and positive or negative, okay? So A plus C less than B plus C, okay? We know something here, the sign of the inequality doesn't change. So we can add constant number to both sides of the inequality without changing the sign of the inequality, okay? And also we can subtract a constant number from the both sides of the inequality without change the sign of the inequality, okay? But in multiplying and division, we get number. If C constant number, if C positive number, positive constant number, okay? Positive constant number. So here I multiply by C of the both sides of the inequality, we get AC less than PC, okay? The sign of the inequality here doesn't change, okay? So, multiplying the both sides or the both terms of the inequality by positive number doesn't change the sign of the inequality. Also, dividing the both sides of the inequality by positive number doesn't change the sign of the inequality, okay? But if C is negative number, so C here negative number, and I will multiply C for the both sides by the both sides of the inequality here, okay? So we get AC greater than PC, okay? Here, not something. The sign of the inequality change to the opposite side. So, multiplying or dividing the both sides of the inequality by negative number, okay? We must change the sign of the inequality to opposite side, okay? Okay, so multiplying or dividing the both sides of the inequality, okay, with the negative number must be changed the sign of the inequality to opposite side. Now, I have example. Find in R the solution set of each of the following inequalities, okay? The first one, 2x plus 6 less than 2. Now, like the equation, I need to separate between the variable and the constant. So I will move 6 to the other side with the opposite sign. We get 2x equals 2x less than 2 minus 6. Okay, so 2x less than negative 4. By divide the both sides of the inequality by 2, we get x less than negative 2. And I said before, the solution set of the inequality in R is written P as interval. It will be written as interval. So the solution set here, negative infinity, negative 2, what? Open interval, negative infinity, negative 2. Another one, 2 minus 2x greater than or equal negative 6. Here, where is the constant number, 2 or negative 2? The constant number here, 2, okay, because negative 2 is a coefficient of the variable x. So I will move 2 to another side with the opposite sign. So we get negative 2x greater than or equal negative 6, negative 2. So negative x greater than or equal negative 8, okay. Take care here. I will divide the both sides of the inequality by negative number, okay? So when we divide the both sides of the inequality by negative 2, we get x less than or equal negative 4, okay? Less than or equal negative 4. I change the sign of the inequality to the opposite side, okay? So the solution set here equals the half open interval, negative infinity, negative 4. Now 5x plus 4 greater than negative 16 less than or equal 9. Okay, I will add negative 4 to the three sides of the inequality. Here, if I add negative 4 plus 4 equals 0. 9 minus 4 equals what? Equals 5. And negative 16 minus 4 equals negative 20, okay? Now, I will divide the three sides of the inequality by 5. So, 5 divided 5 equals x, okay? Negative 20 divided 5 equals negative 4. 5 divided 5 equals 1, okay? So, x greater than negative 4 and less than or equal 1. Now, I have what? I have half open interval, negative 4 and 1. And I said before, the smaller number must be written in the first, in the interval, okay? The smallest number here, where is the smallest number? Negative 4 or 1? Negative 4. So I will write negative 4 in the first. So the solution set equals half open interval, negative 4 and 1. The last exercise here, I have 4x minus 3 greater than 2x plus 1 and less than 2x minus 11. Now I have x in the each side, but I want to put x in one side of the inequalities, okay? So we know something here. I have 2x, okay? So to cancel 2x, I will add negative 2x for the all both sides here, okay? So I add what? Negative 2x. So 2x minus 2x plus 1, 4x minus 2x minus 3, okay? 2x minus 2x minus 11. Simplify it, we get 2x minus 2x equals 0, and here also 0. But 4x minus 2x equals 2x, okay? So here 1, negative 11, 2x. 4x minus 2x equals 2x minus 3, okay? Now, we can add 3 to the three sides of the inequality. We get what? Here, negative 3 plus 3 equals 0, 2x. 1 plus 3 equals 4, and negative 11 plus 3, okay, equals what? Equals negative 8. So we get 2x greater than 4 and less than negative 8. Divide the all sides of the inequality by 2. We get x greater than 2 and less than negative 4. So the solution set equals, good, open interval negative 4 and 2. Open interval negative 4 and 2. Thank you for your listening. Goodbye.